In this section, we're going to talk about instrument programming. Go to my Instruments tab, come down to Programming. Once again, we'll see our sites listed on the left-hand side, and all the various tabs that are available to me in my programming mode are shown here. And of course, the instrument that I have highlighted is shown in the blue bar. Under the General tab, this allows me to view which modem type I have. In this case, it's a CDMA Sprint modem. I also can see or edit the site ID. I can enter or edit the location. I can see the Modbus address for the instrument. The default is 2. I can choose and select or edit my memory mode, which is either slate or wrap. I can choose whether or not to enable or disable the modem. I can pick my time zone, and I can also pick my logging intervals. So in this case, this is under the General tab, my primary call interval is 15 minutes. The secondary call interval is also 15 minutes. Let me describe what these mean. The primary call interval is the interval that will be used under normal conditions. In other words, when the instrument is under normal situations. The secondary call interval would be used under specific alarm or set point conditions are met. For example, if you have a condition set up where you, or a set point set up where you want to log or have the instrument call in more frequently when a rain event is occurring, the secondary call interval can be set up to do that. So in most cases, your primary call interval might be 15 minutes and your secondary call interval might be 5 minutes, for example. 5 minutes is the shortest time that we will allow for a call interval. So this will enable you to see more real-time data under those specific conditions which are set by you. Moving on to the log channels section. Under the log channels, we see our port assignments. Port 1 is a FLODAR, port 2 is an SVS, port 3 is a FLOTOTE, and port 4 is not detected or not being used at this time. It also tells me the selected log channels and tells me we have a maximum of 16 and 14 are currently used. So I want to then look at my selected channels. I look at my different devices and I see that under my logger, my power supply is being logged. So this is logging my battery voltage. Under port 1 in the FLODAR, I'm logging level, velocity, flow 1, surcharge velocity, PMR, and NOS. And if I highlight any of these, I see that I have an option of changing the logging units, the logged units. I also see a primary and secondary logging interval. So, like under the General tab, each channel also has a primary and secondary logging interval available to it. So, again, the same is held true. You can use set points or alarm conditions to change the logging interval from the primary to the secondary logging interval at your discretion. Moving on, under sensor ports, this is where I can make modifications to the various sensors that are attached to those ports. So on port 1, I notice that I have a FLODAR, and I have my level units, my velocity units, and this is my FLODAR configuration. My sensor height, sediment values, level calibration, min, max FFT values, transducer type. We have standard or long range. This is for the ultrasonic transducer. We also have our velocity methods available here and a site multiplier if one is being used for the velocity. Under data quality, you'll see the usual parameters that you see under data quality as if you were viewing this in Floware. Surcharge will give me the information on the SVS sensor, which we know is on port 2. The sensor direction is forward, and SVS can go both in forward or in reverse positions, and we would select that here. The connectivity trigger, the switch that is used to determine whether it is wet or dry, the value is here, and so on and so forth for the SVS settings. The important tab here is our flow tab, and this is where we are going to select the primary device or hydraulic structure that instrument is in. In this case, it's in a circular pipe. We're using area velocity, and the diameter of that pipe is 27 inches. Next, I will go to port 3, and this is our tote 3 sensor port. Our level units are shown here. This is our velocity units. And again, our general tab shows the number of samples, the site coefficient, the sediment values, the level correction or calibration, and of course the sensor offset. So the sensor is offset 4/10 of an inch off the bottom of the pipe. Under data quality, we have our median filters and our cutouts. Again, the important tab here is our flow tab, and we have once again chosen the area velocity or in a circular pipe. Let me use this pull down real quick to show you some of the other options. Those other options might include area velocity rectangular, trapezoidal, U-shaped, or odd. This list will grow as we add more sensors to the FL900 series. In the diameter of this pipe, it's also located, this tote sensor is also located in the same channel as our FLODAR, so it's a 27-inch diameter pipe. After I've made changes to any of these things, I simply click the Save button. And what this does is it will save those changes that were made in the server, and those changes will be pushed to the instrument the next time the instrument calls into the server. So if my logging or my call-in interval is 15 minutes, then it may be up to 15 minutes before my changes take place.